So I'm Kevin, one of the founders of the App Protocol. Been in the computer industry for a long time and kind of a startup junkie. I love startups and I love writing code. So looking forward to today.
Hey everyone, I'm Colin, Constable, Chief Technical Officer at the App Company. I'm really an infrastructure guy who just likes coding. So sort of on the cusp between infrastructure and code. Tyler.
Thank you, Colin. Kevin. Hello, everyone. My name is Tyler McNerney. I actually can't see anyone because I'm sharing my screen, but hopefully I'm visible to everyone else. I'm a technical consultant. That's good. I'm a consultant at the App Company, and I also attend UC Berkeley as a sophomore, and really excited to be here to talk about Flutter and our technology, which is the App Protocol. So let's get started.
So Kevin, why the App Protocol?
All right. Well, so Colin and I about 6 years ago were trying to think of something we've been really passionate about, which is allowing people to own and control their own data, and we were trying to figure out how to do that. And we basically had a couple of aha moments along the way. The first one was, typically when people talk about identity or what is known as identity, it tends to be a big bucket of stuff. So you end up with a bunch of information in some kind of a container that you can use to assert your identity, or ask somebody else to attest to your identity on your behalf, and that's claims and that kind of stuff. And we just said, okay, that's crazy. What we need to do is, we just said, ask ourselves a question: what is the simplest possible thing to do to assert an identity? And what we came up with was a string. So the string is our root. And then we said, holy crap, that's something we could actually build and create a protocol around. And we believe that to make this stuff work properly, what it needs to happen is for the handshake, this is very much a protocol with a handshake, needs to exist as a low-level protocol, not something that you build at the application layer, because that's what we have today, and you've got all these islands of things, and they can kind of interoperate with each other, do single sign-on kind of stuff. That wasn't even close to what we wanted to build. So we wanted to build something where there's a protocol that allows you to securely exchange information between two known entities or two known parties, and it's as simple as it can possibly be. But that's what it does. It allows you to do fully encrypted end-to-end exchange of information between two parties that are known to each other as a result of the protocol. So that's where we started. You want to go on the next slide, Tyler?
Sure.
So I just jump in on the back of that. So we started with writing a protocol, and we had a big decision to make. Was I'm a protocol guy. I'm a network guy. What language are we going to write a protocol in? And we chose Dart. Why did we choose Dart? Well, because we could write the protocol in Dart and then have it run on a light bulb or a server. It didn't really matter. And that was a joy. It was the only other language that could offer that would be C, and that would be a 5-year project rather than the 6-month project. So we fell in love with Dart first. And then as we realized that nobody actually wanted to program at the low level, if we could abstract things further up the Dart tree and then into the Flutter tree, then we'd have something really exciting. So, Kevin, back to you. Sorry.
Oh, no worries. So, what we build. So, if let's say you wanted to build an end-to-end encrypted app of some sort. So, in the last month or so, there's 40 million downloads of Signal in 1 week, and this is in reaction to the privacy or the terms and conditions change from Facebook with regard to WhatsApp. And so so it looks like people are liking things like end-to-end encrypted stuff. And let's say you wanted to build something that was end-to-end encrypted. So again, you could either do that at the application layer, which is a lot of work, and it's really hard. So that's one way to do it. The other way to do it is to use a framework like the App Protocol for building. And what we built is a framework for building end-to-end encrypted apps. And so they're different. They're actually peer-to-peer. And so information again goes between two people. And that gives rise to a couple of interesting things. So one is it's a polymorphic protocol, or the implementation is polymorphic, which means that I can give different information to different people. So because I know who's asking the question, as Colin will tell you, this is the first time you actually have an exchange where you know who the other party is before you have to answer. And so the way that the encryption works is that the answer is uniquely encrypted for the recipient. So if I send something from Alice to Bob, then Bob is the only person on the planet that can decrypt that, whatever I send to him. It could be a picture, a message, a recipe. It could be anything at all. So and that we organize that around a thing called a persona, so you can make it easy for people to manage this information. And that is where the shared libraries and data comes in. So one of the things we love about Flutter is the ability to create libraries that people can really easily use to build an app with. And we'll show you one of those today.
At the bottom, we've got a TCP/IP protocol using TLS 1.2. As I said, all of that's all written in pure Dart. What we haven't mentioned yet is that all of this is open source, so you can look at our GitHub repo and PubDev repo, and you can see all this stuff. You can see exactly how we're doing it. We have our own cloud environment, which is running on GCP. And we also have a standalone local environment, and we're working on a cloud development environment as well. So all the infrastructure is actually catered for you. We've written all that code already. You don't have to touch any of it. Unless you find a bug, of course, and then we'd be super excited about having a PR, because we'd love to get more people involved in that side of things.
And so okay.
He's going to go back a bit, Tyler.
Go back, sure.
Okay, this is fine.
It's fine.
Yeah,
Okay, I'll go back.
So on this slide, on the previous slide, you'll notice that there's a bunch of Flutter libraries and widget libraries, as well as a bunch of base level services that are all wrapped into an SDK. Everything is completely open source. Everything we do is open source. We even have open source apps, which is kind of fun. And then, so basically, again, so this is, I said this before, but essentially apps are different with the app protocol. So an app in the future would be a combination of my data that I'm creating and other data that people are sharing with me. And again, the sharing is done end-to-end encrypted. And the protocol and the reference implementation allows for data caching that's under control of the owner. And so I can, on my phone, have chat messages where I'm combining my messages and somebody else's messages. The messages that are shared with me are encrypted just for me, and vice versa. It's cached on my phone, so it works offline, and it's all local. We're currently using a database called Hive, Flutter Hive, and which is an in-memory database on your phone. It's encrypted at rest, and then we add the PKI and some other encryption tricks from Colin for managing the encryption process, especially for doing like many-to-many encryption, which is always a great deal of fun. But anyway, so the apps of the future combine data together from different people onto your phone, and it's under the owner's control. So Alice could say, I'm going to take my messages away from Bob, and they will disappear from Bob's phone, and vice versa. So Alice is controlling what Bob sees, Bob is controlling what Alice sees, and that's what we think future of apps looks like. And so it's cached, it's available offline, and because it's in-memory database, it's really fast. It's a very snappy performance. You're not going off to a cloud server to get data. You're actually, after you do that, then you actually are storing it in cache. And everything is peer-to-peer, so you don't need to have a back-end server for an app anymore, which also allows one other thing which is interesting, which is apps are able to access potentially all the data that you want to share with them, because it's your data on your phone, and your apps can use whatever data of yours that you want. So apps become kind of a lens onto your data and not have a hard-coded relationship or between, let's say, a back-end data model and a front-end data model. The information exchange is via a protocol, which makes it easier to interoperate between apps with data.
So as we said, we're all open source. You can see everything. You don't have to, as a developer, you don't have to worry about the back end. This leads right to surveillance-free applications. Nobody's surveilling you because there's no place to surveil and everything's encrypted anyway. And as you'll see from Tyler, very rapid development cycles. We'll see reuse all the components we've written, and we share as much as we can. So maybe Tyler, you can show us this in action.
Sounds great. Thank you so much, Kevin and Colin. So just a fair warning, I am doing a lot of processes on my laptop, so the demonstration will be a little bit slow, but let's pull through nonetheless. So I currently have the Hello World application running on this Android emulator. The Hello World application being the most basic beginner-friendly application or demo app that we've provided for developers who are trying out the app protocol as well as Flutter for the first time. So I currently have the complete version running, and I'll just go through a quick demonstration of this app before we dive into the incomplete version, and I'll just illustrate how easy it is to code with Flutter and Dart to make a beautiful application. So right now I have a testable @sign, and @sign is basically your account on that protocol. I currently have Barbara, but you can really choose any one of these @signs. And let's go ahead and log into Barbara's secondary server. So it's going to take a little bit to authenticate properly. But once you do authenticate successfully, in the console, you should see an auth success message appear. So the Hello World application is relatively simple. You can basically add key value pairs to Barbara's secondary server. So I'm going to go ahead and do that. Since this is a Hello World app, let's go ahead and put hello as the key and world as the value. I'm going to go ahead and update Barbara's secondary server. And once I scan Barbara's secondary server, I'll see the hello key appear in the drop-down menu. And once I look up the value corresponding to hello, I get world. And if I were to hot restart this, you will notice that this data does indeed persist across Barbara's secondary server. So let's take a closer look at the code that is doing this. And for the sake of giving a better demonstration, I think I will go ahead and stop this process and open up the incomplete version of this application. So just to give a little bit of context into what this application is doing, a lot of the components that you saw in the application was Flutter. A lot of these you might recognize, like the list tile widget, as well as the flat button widget. All of these are just native Flutter widgets and are very easy and intuitive to use. And you can see from top to bottom how those Flutter widgets are incorporated into this application. Let's take a look at the dependencies really quickly. So you have some of your traditional Flutter dependencies. And the three dependencies that are app protocol related are @client mobile, @server status, and @demo data. And each of these essentially allow you to use a lot of pre-built app protocol verbs and methods to perform tasks like authentication and data persistence with relative ease. So I'm going to go ahead and start off with the login method. And for the sake of time, I'll go a little bit quickly. But as you might have noticed in the introductory screen, what this login method does is it takes in an @sign, once again, your account on the app protocol, and it authenticates into the microserver associated with an @sign. So I'm going to just write a couple lines of code to accomplish this. And on a side note, the most important object that we have in this file is called the server demo service variable. And this is essentially a singleton of the service file that we've provided in this Hello World application. And the service file has all sorts of app protocol methods and verbs built in for you so that you can use a lot of these methods very easily. So let's go ahead and get started. Assuming that the @sign that was passed in is not null, I'm going to want to call the method called onboard, which has an optional argument called @sign, and inside of this, I want to pass in the @sign variable, which we've defined at the very top of this class right here. Assuming that we onboard successfully, I want to navigate to the next page. And the way that we do that is pretty simple. This is a pretty common method that's used in most Flutter apps, which is navigator.pushReplacementName. It takes in a builder context, which we can just pass in as the context. And for the route name, which we've already predefined in the main.dart file, I'm just going to pass in the name associated with the home screen. That's really all that there is to it. But the way that the app protocol works, you can't actually authenticate into the @ the first time. And the reason being, the way that the app protocol works, we use the keychain manager to basically look for the keys that you need to successfully authenticate into an @ secondary server. But the first time you onboard, those keys are not going to be in the keychain manager. So instead, we want to call a different onboarding method to actually embed those keys associated with an @ into the emulator's keychain. Assuming that an exception is thrown, we're going to want to call a different method. And this method is called authenticate. And this takes in a couple of arguments, namely the @ as well as a JSON data string, which we've defined at the very top of this login method. And this JSON data basically just encrypts the keys associated with a particular @ And I'm just going to pass in the JSON data object there. And we also need a decrypt key so that we can actually decrypt this JSON data. And for this, I'm going to call the @demo data library and call the AES key map and pass in the @ as the key for that map. Let's just end these with a semicolon. And this is the most complicated methods in the app protocol, but this is essentially all you need to successfully authenticate. Although let's not forget that I'm just going to copy this right here. We want to navigate to the home screen, assuming we authenticate in this fashion. This is the entirety of the login method. And once you write these couple lines of code, you will have successfully authenticated into Barbara's secondary server. And from there, you can use a bunch of app protocol verbs like update, scan, and lookup to manipulate key value pairs in Barbara's secondary server. So let's go ahead and write down these to-dos. And just once again, we're currently on the homescreen.dart file right now, and this is exactly what you see on this emulator window, where if you go from top to bottom, you'll notice a lot of the corresponding components, like a list tile with the update text you can see right here. Scrolling a bit down, you're going to find the scan list tile right here. And all the way to the bottom, we have the lookup list tile right over here. So let's try to replicate what we did over here in the code. Namely, we want to be able to take in a key value pair and assign it and add it to Barbara's secondary server. And once we have it added to the secondary server, we want to be able to scan it and get a list of keys from the secondary server, select one of those keys, and then look up the value corresponding to it. And in fact, that is a relatively complicated process. And if you weren't using the app protocol, this procedure could take many lines of code to accomplish. But let's try to demonstrate how we can do this with just a couple lines of code. So update, we want to add a key value pair to Barbara's secondary server. And the way to do that is let's first initialize an @key object. Following this, once we have this @key object, there are a number of attributes associated with it that we can populate to our advantage. So it has a key attribute, and we want to pass the key private variable to it. And just to demonstrate what each of these variables mean, key and value represent the key value pair that's passed into the update list tile. The lookup key is the key that we select from the drop-down menu that was in the scan list tile. And the scan items list is what's passed into this drop-down menu item once we retrieve the list of keys after calling the scan verb. OK, so scrolling all the way back here, we want to assign the key attribute for the @key object. And once we do that, we also want to identify whom we're sharing this data with. So for the sake of this Hello World application, we're just going to simply assign it or share it with ourselves. But the power and beauty of that protocol is that you can really pass in any @ that you'd like. And you're guaranteed that this piece of data gets shared only with that person you identify here. In fact, not even the company can decrypt what's shared between two @. And after this, there's really just one line of code left to update Barbara's secondary service. And we're going to want to call the service.dart object one more time. And this file is just called @client service. And we want to call a put verb. And this takes in an at key, which we've identified earlier, as well as a value. Okay. Let's keep on going since we're running a little bit out of time. Scan essentially scans Barbara's secondary server to get the list of keys. To do this, let's first initialize the list object, call it response, and let's assign it to the following verb, get at keys. And this takes in a shared by optional argument, and we want to pass in the @ sign here. So assuming that this response actually has a bunch of at keys inside of it, we want to basically strip away the at key object and just return a key instead. And let me do this correctly. There we go. OK, so I'm going to make a new list, and this time it houses strings. Let's call it the scan list. And we want to set this to the result of mapping this response list. Over here, let's just call the arrow function. And we just want to pull the key attribute, as we did up here, from this at key object. And let's make sure to convert this to a list. Assuming we do this successfully, we want to call setState, our best friend in Flutter. And let's just set scan items, which is once again the variable we defined at the very top of this class. Let's set scan items to the scan list. And that's really all we need for scan. The final verb lookup will take in a lookup key and spit out the corresponding value. And let's go ahead and do that. So once again, we want to make a at key object exactly the same way that we did for the update verb. We want to pass in the lookup key to this at key object. And we also want to identify with whom this at key object was shared with. Assuming we do that correctly, let's identify another string and call the get verb on the service object. And this takes in an at key object. Let's just pass in lookup here. Okay, so assuming that the response is not equal to null, we want to call setState one more time. And we want to assign the lookup value, which is another variable that we've defined. And it's basically this variable right over here. We want to set that equal to the response. And that is all we need. So we've implemented a bunch of very complicated tasks like authentication and data persistence with really just a few lines of code for each verb that we identified in this project. And that is really only possible or very easy to accomplish with Flutter as our UI and the app protocol as your automatic backend service. So this demonstration is all fine and dandy, but you may be wondering, well, what more can I do with the app protocol? This is just a Hello World application. So Colin has the @chats demo application running on his very own device, and he will demonstrate how you can use the app protocol to accomplish one-to-one messaging. So it's pretty exciting. Colin, are you good to go?
I think so.
Alrighty.
You can see my screen, I guess. That's the...
Yeah. I
Yeah,
believe
you
we can see it.
All right. That's good. So essentially, there is a Flutter widget that you can use. It's called what is it called now, Tyler? It's just a chat widget? I can't remember. Sarika put it on, who I know is listening.
That's correct. In fact, let me show you real quick. So some of you guys may be wondering,
yeah.
well, yeah, how exactly can you implement a chatting application with the app protocol? So I will just go ahead and open the project associated with this chat application. And the answer, as I like to say, is really just one line of code. So here we have the incomplete version of the chatting application. And it has a couple of screens. And you're going to notice a lot of similarities here. Like, oh, well, this is the exact same authentication method that we wrote for the Hello World application. And if we move on to this third screen Dart file, you're going to notice that there is, a scaffold widget, and it has a body, but we've currently set it only to a container. But we want to have a chat screen here, and implementing a chat screen with just one widget may sound like a ridiculous task, but we have an app protocol library called @chatflutter. And what this does is it takes in a @ and another @ that you want to chat with, and based on that information, it makes a chat screen widget like that. So to implement a chat screen or a messaging application with that protocol, you need to just call the chat screen widget from the @chatflutter library, and it's as easy as that, just one line of code. So with that said, why don't we move on to the demonstration? Yeah.
And a huge shout out to Sarika who put that together. Pretty amazing stuff. So I have here a Android machine on the right. You can see this here, and on the left, an iPhone. I'll prove it's an iPhone because you can see it there. We're going to have Alice and Bob talk to each other. So we're going to say, I'm going to log in as Alice on there. We'll fire up the application on the Android. And Alice wants to chat with Bob. So you can see in the background, all those to and from @ are being set up. And I want to go to a chat window. And over here, Bob is going to log in. And Bob wants to talk to Alice. And we can navigate to the chat window. All of this code, by the way, is available to you. You can get to see this. Let's see whether the demo gods are with us. And we'll see. Yeah, demo gods. Look at that. I see demo gods on both screens. Yay. So you wouldn't believe how much technology there is going on here. So I am running these are two physical devices. So just to prove that they are two physical devices, there's the one app and there's the other one up. So these are real devices. And you can see they spun round as soon as I move them around. And I'm sharing my screen, and then Tyler's sharing the screen there. So that is that single line of code working in action. So hopefully you guys saw that. And there was a question I noticed in chat, which we should probably answer. Which is, how does all this work if there's no servers? Well, the fact is there is a server, and the server is a microservice, and it's dedicated just for that @. So in this case, Bob and Alice have their own microserver, and that's run in the cloud. It's actually run in GCP, and it can run anywhere, and it can be owned by anyone. We're just running them at the moment because there's nobody else to run them. But if you want to run your own, you can definitely run your own. And you can see how to do that when you go to @dev and see how the developer environment is put together. You'll be able to see it all. Again, all that code's available to you to look at. So that microservice is written. Microservice is written in pure Dart. It runs in a Docker container, and it has the grand sum of 4 megabytes of memory. So this really is a microservice. So that enables you to store encrypted data for somebody else, and so they can pick it up when maybe your phone's offline, or maybe you've switched off the internet, or maybe you're just not available for the moment. So that's where things can be stored. The secret is the keys are always on either party's mobile devices, and the key that Kevin and I were waiting for, and we couldn't do this. Why we couldn't do this 6 years ago is because phones back then were just not powerful enough to create the sort of crypto keys that we needed. So yeah, that's how that works. So if you want to get started, if you actually want to run all this stuff yourself, you can go to @dev. You can look at our Foundation GitHub repo. You can see everything there. Probably the most active part of the company at the moment is our Discord community. If you scan that QR code, you can come join and just say hi. That would be awesome. Back to you, Tyler.
Sounds great. Thank you so much, Colin. And I know we are at the 30-minute mark, so just to reiterate, all of our information is up on our dev site. So please refer to @dev to find all of our demo apps and just about anything you need to start your journey with the app protocol. The QR code for the Discord community is there, and if possible, if we could put it in chat, that'd also be great. But otherwise, thank you so much for having us. We love Flutter, and I've personally made a lot of Flutter applications before with the app protocol. So we're really happy and glad to be here. But just to celebrate the 30 Days of Flutter challenge that has been going on, the ad company is giving away 100 free Flutter courses to those who join our Discord community. So we really hope to see you guys there. I think that's everything.
One more question. Actually, it's also what I wanted to ask. Thanks.
Yeah.
So basically, if the user is not available, I'm offline, Anand offline, how would we find our data?
Yeah, that's that's a fantastic question, and that's one of the reasons why every at sign has its own microservice. And essentially, it's your sort of your at sign guardian. It will actually answer those questions if it can, and if it can't, then it will store that question. And when you come back online, you'll get what we call a notification, and then you can deal with the notifications. So again, all of that code's available. You can see it. Probably the best thing to look at for notifications, there's a full-scale app that's on both stores, iOS and Android, called Atmosphere, and it's for sending a encrypted file from person to person. And one of the things it does is actually notifies you that somebody sent you a file, so you can actually see how that verb works and how those methods work. And if you're not there, then it will get stored, and next time you connect, your secondary server will store it, and then it'll give you the notification. It's actually two bits are really tough to do. One is notifications, and the other one is synchronization. And obviously, all that stuff's abstracted away for you.
Okay. Actually, I have a follow-up question. Looks like you are saving data and you are hosting these microservices.
Yeah.
Who will pay for backend? So basically,
how do we make money? That's a good question. Kevin, how do we make money?
Well, so we're I start off saying, so we were crazy enough to say we're going to write a server in Dart. So we actually have a cloud server that's purely written in Dart. So we start with that, and it's super efficient. So it runs in literally 4 megabytes of RAM, not gigabytes, 4 megabytes of RAM. And so first of all, we drive the cost down to as low as possible. That's the first answer. And the second is we pay for it. So every person gets a free microservice in the cloud running on GCP that we can't look inside. We can't see anything. And that's provably true. So we can prove that we can't see your data.
Unless it's public.
Unless it's public. And then it's public. And then so from there, and if you want to run your own. If somebody wants, if telco or somebody wants to run them, great. That would just save us money. But right now we're running them, and we built it to scale to 50 billion endpoints, at least from the directory side. So it's built for internet scale for sure. And then the other thing that we do, so most of the data is actually, it starts on your phone, so it's actually literally stored on your phone, and but it's also it's synchronized to this microservice in the cloud that can respond on your behalf if you're offline or whatever. And there's an event model so that data changes can propagate between devices, between the person sharing something, and the recipient of that information could all be monitoring those notifications. So it's a protocol that allows you the exchange of information, including notifications of data change events. So that's but we're doing that the way we make money. We actually are just selling at signs. So you can get at signs for free, and most people do. So we're assuming that almost everybody will get a free at sign, but some people want to have their own personal brand. So I don't know, at Kim Kardashian or at whoever will want to have their own personal brand. So they'll buy an at sign, and it's kind of like a domain name, but it's a single at sign for you or your company or whatever, and that over time will hopefully start to replace all the all the individual identifiers on Instagram and Twitter and TikTok and so on, and have a single name for your stuff. And so ours is @company, for example, on Twitter. So it starts to give you your own personal unique identifier. And so there's enough people will pay for it, we believe, that will allow us to provide those services for free. And that's it. And the best news is, if you're a developer and somebody buys an @ because of the app that you build, you get a 20% commission on that @ So it gives app developers a new revenue stream that didn't exist before. So, and that's 20%. Of $100 @ is $20 per new person. That's not chump change. So we think that's pretty interesting too. So we're the only development platform that actually pays you money that I know of. So that's kind of fun.
Okay, I like how you switch the topic from why we don't pay for your service and how you pay back.
Yeah.
Actually, I have a bunch of questions, but for sake of time, I will take maybe this one. It's not fully question, so it's coming from Deepak. That looks like it's great to have some Dart protocol, and I had a related question. Looks like you started a while ago to work on that, and basically Dart before Flutter, maybe like a few years ago, wasn't so popular, and it looks like it was a pretty crazy decision. How did you decide to use Dart? So our next topic, Brett will cover something from that, but how did you do it?
So this is the power of the Dart and the Flutter community. So it was me that made the crazy decision. So it was on me. But I was advising another company, and they had a really cool idea about using mobile devices and extending private branch exchanges, so extending corporate phones out to mobile phones. And their CTO said, what we should use is this Dart stuff because it's really cool. I'm like, well, how cool is it? And he said, well, you should see how cool it is, because I've been working with the Flutter community in New York City. He lives in New York City. It's really super vibrant, and you should take a look. So like, okay, I'll take a look. So when Kevin and I were sitting down, we said, like, we could write this stuff in C, but it's going to take forever. But like, let's just start with Dart, because Richard said it's a really cool thing. And Richard's a trustworthy guy, so we trust Richard. And so we started writing some code, which was really just demo code. And it slowly got out of hand, because every time we turned into something that was difficult, like, an in-memory database is difficult. And the HiveDB devs didn't have everything together back then. But we reached out to them and said, what about this? What about that? And they were awesome. I mean, just incredibly cool. And then we needed some crypto libraries, and the Pointy Castle guys were out there, and they were cool. So it was really complete. It was the community that pulled us in. I mean, we couldn't have done any of this without the Dart and Flutter community. I mean, this wouldn't have happened.
Yeah, Colin found a bug in the Pointy Castle stuff too. Both a double unicorn bug. So we support the full Unicode character set, and so you can have emojis. Your @ can be emojis if you want, or Chinese characters or whatever. And at the moment you can only register with Latin and emojis, but the underlying code supports the full character set. And Colin found a bug for, if you put a double emoji onto Pointy Castle, it'll throw an error. And so
it was the UTF-8 to UTF-7 converter, because HiveDB uses as its key, it uses UTF-7 for all sorts of good reasons. So it meant that we had to convert a UTF-8 to a UTF-7, and that library has been around for a decade or two. But obviously nobody had ever tried to convert a double unicorn into UTF-7, because when they did, the whole thing fell over. And not only was the problem in the Dart code, the problem was in the convert code in Dart. But that had been sort of cribbed from a library that was written in JavaScript, I don't know, a decade before. And it was still in that one as well. So we got it fixed in the Dart library, and then we had to get it fixed in the JavaScript library that it was based on. So I did that makes me so happy when the community does that sort of stuff.
For me, German, the test has always been, every time we had a discussion on what to write this stuff in, I'm like, light bulb test. So I want to be able to run my code in a light bulb or a thermostat or a wearable or a whatever. So it's got to be compilable and efficient to run on anything you could imagine. So Dart was the technically the best answer for running in a light bulb. That's my test.
And nice clean binaries. I mean, really nice clean binaries. And it's going to get better with the null safety stuff. Those binaries are going to get tighter and tighter. So yeah, it was a mad decision, but I think it was the right mad decision as it turns out.